So today we'll be discussing about biological filtration of sewage. So coming on to the sewage treatment processes, we know that the sewage will be undergoing preliminary treatment followed by secondary and tertiary treatment. And now I would like to discuss about the secondary treatment of sewage through biological filtration. So this effluent from the primary sedimentation tank will be consisting of 60 to 80% of colloidal matter, which is unstable organic matter. And during the secondary or biological treatment, what happens is that the organic matter from the primary clarifier will be removed by the process of oxidation or nitrification. So the character of the organic matter which is coming from the primary treatment is changed by different methods. Two different methods are there, that is attached growth process and suspended growth process. Attached growth process is taken by the process of filtration, and activated sludge process is coming under the suspended growth process. So all the secondary treatment processes are designed to work under the principle of aerobic decomposition. That is, the aerobic bacteria will be acting upon the organic matter and decomposing or stabilizing them in the presence of oxygen. Coming on to the biological filtration processes, the filter units which are used in secondary treatment will be consisting of open beds which are composed of coarse aggregates, and the incoming wastewater is allowed to pass through this open beds, and this open beds will be acting as the contact surface for growth of aerobic bacteria. So the aeration is naturally provided and the organic matter is decomposed in the presence of oxygen, and the stabilized effluent from the filter unit is allowed to pass to a secondary sedimentation tank where this is allowed to settle. So there are different types of filters used in sewage treatment: contact beds, intermittent sand filters, trickling filters, and many other miscellaneous types of filters. So moving on to the trickling filters. So the trickling filter is employing an attached growth process. That is a process in which the microorganisms responsible for treatment are attached to an inert packing material, which is the filter media. So this trickling filter will be consisting of a cylindrical tank which is filled with the filter media, which is having a high specific area material. And the sewage is allowed to trickle down by means of rotary distributors, and the percolating sewage is collected at the bottom of the tank through a well-designed under drainage system. So the figure shows a conventional trickling filter. Here you can see that the incoming wastewater is allowed to pass through a siphonic dosing tank through an influent pipe, and it will be passing through a central influent column, and this from there the sewage is allowed to trickle to the, or it is allowed to spray to the filter medium through a rotary distributor which consists of 4 arms generally, and the sewage is allowed to percolate through the filter media where it is getting stabilized by oxidation or nitrification, and then the percolating wastewater which is stabilized is allowed to pass through the under drainage system, which is sloping to a central effluent channel, and the central effluent channel will be carrying the wastewater to the secondary sedimentation tank. So as the sewage is trickling down, a microbial layer will be developing on the surface of the filter media, and that layer is known as slime layer, and the oxidation will be carried out in this particular layer, and as time passes this biological slime layer will be growing in thickness, and as the thickness increases the aerobic layer will be limited. That is, the penetration of oxygen will be limited and the bacteria will be losing their ability to cling to the media surface. So what happens then is that the incoming liquid will be washing the slime off the medium and a new slime layer will be starting to grow, and this process is known as sloughing. The slapped off film as well as the treated wastewater will be collected together by the under drainage system. And another purpose of this under drainage system is that it will be allowing the passage of circulation of air through the filter, so as we can maintain aerobic conditions inside the filter medium. So after that, the collected liquid is passed to a settling tank which is used for solid liquid separation. Now going on to the constructional details of conventional trickling filters. We have mentioned it earlier, it consists of a circular watertight holding tank, then there will be a distribution system consist of rotary distributors, then the filter media will be made up of broken stone, slag or gravel, and there will be an under drainage system which consists of vitrified clay blocks with top openings, and they will be laid on a RC floor sloping towards a main effluent channel. And this is a typical cross section of a conventional trickling filter, consists of an influent pipe, rotary arms, filter media, under drainage system and a central effluent channel. So here you can see the photo of a conventional trickling filter. Here you can see the rotary arms sprinkling the wastewater to the filter media. Now there are two types of trickling filters, low rate filters and high rate filters. The main difference is that high rate filter will be filtering, or will be in this the sewage will be applied at a much higher rate than the low rate filter. And there's one more difference is that there's a provision for recirculation of sewage through the high rate filter. That is, a part of the filter effluent will be recirculated to the primary settling tank, or it will be repassed through the filter. So here you can see the layout of low rate filter, a single stage high rate trickling filter as well as two stage high rate trickling filter. So this recirculation has got many advantages, that it will be diluting the flow, it will be ensuring a long contact period, and it will be increasing the efficiency by reducing the BOD load. Now we can see the advantages of trickling filter. Here the rate of filter loading is high, the effluent is stabilized, the working is simple and you don't need a skilled supervision, and they are flexible in operation, they are self-cleaning as we are allowing back washing, and the mechanical wear and tear is comparatively lesser. So what are the disadvantages of trickling filters? The head loss through these filters is high, the construction cost is high. The problem is that we cannot treat raw sewage, you will need a primary sedimentation tank, and there will be some operational troubles like fly nuisance and odor nuisance. So here you can see the design considerations of trickling filters, both low rate as well as high rate. The hydraulic loading, organic loading is different, the depth of filter media is different for both, the size of filter media is different, and the land area required is more for low rate trickling filter while that is less for high rate trickling filter. There's continuous application for both, but the low rate trickling filter is less flexible and requires less skilled supervision, while the high rate filter requires more skilled supervision and you're providing recirculation, and the dosing period is higher for low rate trickling filter, while that is lesser for high rate trickling filter. Now we are moving on to the next type of filters, that is contact bed. Here also we are employing biological filtration. So in contact bed filters, the sewage is kept in contact with the filter media for a particular time, for a particular period, and that is known as first contact period. And during this stage, the fine colloidal matter will be trapped in voids between the particles of filter media. And what happens? The aerobic bacteria present in the sewage gets attached to the filter media as biofilm, similar to the slime layer as we have discussed in the trickling filter. And here also aerobic decomposition of organic matter is carried out by the biofilm. Then for a certain period, the filter is left empty for a certain period for availability of sufficient oxygen, and this is known as second contact period. So moving on to the construction details, here also there is a watertight rectangular tank which is filled with filter media. The filter media may be gravel, ballast or broken bricks or stones. Usually 1 to 1.8 meter depth is provided. The tank is dug below ground level and is provided with concrete lining. And there is a siphonic dosing tank to serve 2 or 3 contact beds at the same time. And the dosing tank will be receiving sewage from primary sedimentation tank, and this will be supplying to different contact beds turn by turn. And here also the sewage will be percolating through filter media, and this will be collected by an open jointed under drains. And the effluent coming from the effluent pipe will be taken to a secondary sedimentation tank for settling out the organic matter. Here you can see the figure of a contact bed. There is a siphonic dosing tank from where the influent water is sprayed to the filter media through distributing pipes. There is a concrete lining. Then through the under drain pipes, the filtered effluent water is moved to the effluent pipe and later to secondary sedimentation tank. So, moving on to the operation of contact beds. Initially, the sewage allowed from dosing tank is allowed to fill the bed completely. Then it is allowed to stand to a depth of 5 to 10 cm. Then the outlet valve is closed during filling, and this filling will be taking about 1 hour. Then the dosing tank is then closed and the sewage left over the bed as it is for 2 hours. And this period is known as first contact period. And what happens in this stage? The colloidal matters present in the sewage will be transferred to filter voids during this period, and the outlet valve is then opened and then the sewage is removed slowly. This is the first period. Then after that the bed is kept empty at rest for a period of 4 to 6 hours. And this is known as second contact period or empty period. During this period, organic matter will be trapped in the voids in the filter media, and this will be oxidized by aerobic bacteria. So one full cycle of operation will be taking about 8 to 12 hours. And the stabilized organic matter is finally washed down the contact material in the next emptying of the tank. The advantages are that this contact beds will be removing 80% of suspended solids, 60 to 75% of BOD, and the rate of loading is 110 liters per day per square meter of the filter for a bed of depth 1.2 to 1 meter. And as time passes, the rate of loading gets reduced due to the clogging of filter media. Now moving on to the intermittent sand filters. They are more or less like contact beds, with the difference that the contact media is finer and there is no concrete lining around the filter media as in the contact bed. Here the rate of loading is lesser, and the sewage dose is applied for 24 hours on one bed and then applied on second bed, keeping the first bed at rotation. So parallelly you can function 3 on bed, 4 beds in rotation. Now construction is similar. There will be an underground rectangular tank. The difference is that there won't be any lining, and the sand will be filled in a depth of 0.75 to 1.05 meter. The bottom of the tank is sloping towards under drains. There will be a siphonic dosing tank, and the sewage will be spread intermittently over the filter bed through distribution pipes. The figure is shown similar to the contact bed, but the difference is that there won't be any concrete lining. So here also the effluent obtained contains suspended solids less than 10 ppm, and the BOD will be of less than 5 ppm. But the disadvantage is that the intermittent sand filters requires large land areas and huge quantities of sand, and there will be very low rate of loading. So usually it is used for treating smaller quantities of polluted sewage from hospitals or isolated commercial and industrial institutions. So now we have discussed about the different biological filtration techniques, that is Brooklyn filters, intermittent sand filters and contact bed. All will be using the principles of aerobic decomposition. Thank you.